Hello, in this video for Chapter 5 for MAC2233, Calculus for Business and Social Sciences, we're going to be talking about elasticity. So let's say you manufacture an extremely popular brand of sneakers and you want to know what will happen if you increase the selling price. Well, common sense tells you that demand will drop as you raise the price. But will the drop in demand be enough to cause your revenue to fall? Or will it be small enough that your revenue rise because of the higher selling price? So the idea is this: you have a price. If you raise it, you'll make more money, but if you lose too many people, then you may lose money. So the question is what that balance, and that's what elasticity is going to talk about. So for example, if you raise the price by 1%, you might suffer only a 0.5% loss in sales. In this case, the loss in sales will be more than offset by the increase in price, and your revenue will rise. In this case, we call it inelastic because it's not very sensitive to the increase in price. On the other hand, if your 1% price increase results in a 2% drop in demand, then raising the price will cause drop in revenues, then we say it's elastic because it reacts strongly to a price change. So we can use calculus to figure this out. So the formula for elasticity of demand is the percent drop in demand per percentage increase in price. So the way we look at that in a formula is to find elasticity. The formula starts with negative, the derivative of demand with respect to price, times P for price over the demand. And when you plug into this formula, if your output is greater than 1, then your price is elastic. The demand is elastic, so you should drop your price. If you plug into this formula and your output is less than 1, then you're inelastic and you should raise the price. So above 1, lower the price. Less than 1, raise the price. So what are we trying to reach? We're trying to reach unit elasticity, which is we get an output in E of 1. So here's an example. Suppose the demand equation is Q equals 20,000 minus 2P, where P is the price in dollars. So P is price. Well, let's find the elasticity. To find the elasticity, it's negative, derivative of demand, derivative of 20,000 is 0, derivative of minus 2P is minus 2, times price, P, over the demand, which is 20,000 minus 2P. So we simplify this by negative times negative is positive, 2 times P is 2P over 20,000 minus 2P. Now, here's our elasticity function. If we decide to charge, let's say, $2,000, we plug 2,000 in for P, and our output E is 1/4. Well, 1/4 is less than 1, which means we're inelastic, so we should raise the price. Okay, so let's raise it to 8,000. Well, when we raise it to 8,000, plug in 8,000 in for P, we get an E of 4. Well, 4 is greater than 1. At this point, we're elastic, which means we should drop our price. So 2,000 was too low, 8,000 was too much. Let's say we get lucky and we plug in 5,000. Plug in 5,000 for P, and our output is 1. That is our best price to maximize revenue. So let's do an example. We can also talk about income elasticity, but we're not going to focus on that in this chapter. But it is possible to talk about income elasticity, but we're going to focus on price elasticity. So suppose the demand equation for Bobby dolls is given by Q equals 216 minus P squared, where P is the price per doll in dollars and Q is the number of dolls sold per week. So P is price, Q is quantity, but this is quantity demand. Well, we first find our elasticity. So the formula goes negative, derivative of demand, derivative of 216 is 0, derivative of minus P squared is negative 2P, times P is for price, over our Q, which is 216 minus P squared. We simplify by saying negative times negative is positive, 2P times P is 2P squared, over 216 minus P squared. So our elasticity function is 2P squared over 216 minus P squared. So let's put that in the calculator. So we go to our calculator, we go to y equals, clear what we have in there. So we're going to put 2P squared, 2x squared divided by parenthesis 216 subtraction x squared. Close parenthesis. Okay, so let's see what happens when we plug in 5. If we plug in 5 in for p, we get 0.262. Let's check that in the calculator. So we've already set up our table, second graph for table. We plug in 5, and we get an elasticity of 0.26178. And going back to our chart, that would make it inelastic, so we should raise the price. Okay, let's try $10. So if I plug in 10 in for P, we get 1.724. Let's check that in the calculator. Plug in 10, 1.724, which would make it elastic, which means we should lower the price. So 5 is too low, 10 is too much. So the question is, how do I find the best price? I could keep guessing until my output is 1, but we can solve for this. And there's some calculator examples here where you can do it in the calculator, but this would be bonus material. So if we want it to equal 1, let's use some algebra. So we do 2p squared over 216 minus p squared set equal to 1, or 1 over 1. Cross multiply. 2p squared times 1, 2p squared. 216 minus p squared times 1 is 216 minus p squared. Add p squared, add p squared. We get 3p squared equals 216. Divide by 3, divide by 3. P squared equals 72. To remove the squared, we square root both sides. P equals positive or negative 8.49. But we're talking about price, so 8.49 is the best price. But let's check it. So I go to my calculator. I type in 8.49. And it gives us an output of 1. Okay, so we found the best price, $8.49. Well, what can we do with that? Well, remember, revenue is price times demand. Our demand is 216 minus p squared, p for price. If I distribute the p, we get a revenue function of 216p minus p cubed. Then we know what the best price is, which is $8.49. So I plug in $8.49 in for both. So we find our maximum revenue of $1,221.88. So our best price gives us our maximum revenue. Now remember, how do I know when it's inelastic or elastic? Well, 0 is the lowest price we can charge. And anything lower than $8.49, between 0 and $8.49, that's when it's inelastic. That's the numbers that told us we should raise the price. But anything above $8.49 would be elastic. That's when we should lower the price. Okay? Thank you so much, and that concludes Chapter 5.